Institutional wallet architecture is never just a vendor choice. It connects custody providers, signing controls, key protection, and transaction workflows into one operating model. In this topic, we'll look at how to evaluate those pieces for secure, compliant production platforms. We've built the architecture from market needs through tokens, settlement, and custody workflows. Next, we turn those designs into implementation choices: custody providers, wallet tooling, and enterprise key protection. For institutions, wallet infrastructure is an architecture fit question, not a vendor checklist. A custody platform may handle wallets, approvals, and signing, but it still depends on policy controls, chain connectivity, and integration with core systems. Key management tools protect the deepest layer: secrets, certificates, recovery materials, and signing keys. The right design supports regulated issuance, investor servicing, settlement, treasury operations, and audit evidence within the institution's operating model. Vendor selection is really a risk architecture decision, not a brand decision. Start by matching the custody model to your control requirements: qualified custody, MPC, cold storage, hot wallets, or hybrid designs. Then test whether the platform integrates cleanly through APIs, webhooks, SDKs, sandboxes, and policy tools. Finally, verify assurance and operating fit, including certifications, audit trails, segregation of duties, settlement workflows, SLAs, disaster recovery, support coverage, and asset breadth. Score evidence, not promises. Fireblocks is a useful example of how institutional wallet infrastructure fits into the broader operating flow. A treasury, custody, or issuer platform submits a transaction through APIs. Policy rules check roles, limits, destinations, and required approvals before MPC signing occurs. Once approved, the transaction can route to a blockchain, exchange, custodian, bank, or DeFi venue. In architecture review, focus on dependency risk, chain support, policy granularity, audit evidence, and disaster recovery. Other platforms solve related problems, but they are not interchangeable. Copper is often strongest when custody connects directly to settlement and prime brokerage workflows. BitGo is commonly chosen for regulated custody, multi-sig infrastructure, and enterprise APIs. Ledger Enterprise leans toward institutional self-custody, governance, and hardware-backed control. For any provider, compare who holds responsibility, which jurisdictions are covered, how mature the APIs are, and whether the operating model preserves the control your platform needs. MetaMask Institutional takes the familiar browser wallet pattern and wraps it in controls an organization can govern. A fund administrator might use it to update a token contract, vote in governance, or access a DeFi workflow, while custody, compliance, and approval policies sit behind the action. The convenience is real, but so is the risk. Phishing pages, spoof transactions, and weak endpoints can bypass good intentions. Pair browser access with allow lists, simulation, training, and lockdown devices. Wallet tools solve different parts of the transaction experience. Safe is strongest when control matters: multi-sig approvals, treasury governance, and programmable ownership. Wallet Connect focuses on connection, letting users authorize dApps from wallets they already trust. Embedded wallets optimize onboarding by hiding key management inside the app flow. Account abstraction goes further, turning accounts into programmable policies with sponsored gas, session keys, recovery, and spending limits. A safe-style wallet turns critical actions into a controlled approval workflow. Someone proposes a transaction, signers review it, and execution only happens after the required threshold approves. That is valuable for minting, burning, upgrades, treasury transfers, and contract ownership. Modules and guards can add policy checks or automation, but they also add risk. Before relying on safe for governance or reserves, evaluate chain support, signer rotation, upgrade paths, module permissions, and emergency recovery. Wallet integrations create trust boundaries. Wallet Connect adds flexible session-based approvals across devices. Browser wallets make smart contract interaction fast, but depend heavily on endpoint security and verified domains. Mobile wallets improve usability with biometrics and push approvals, but device compromise remains a risk. For institutional issuance, convenience must be wrapped in controls. Allow listed dApps, short session expiry, transaction simulation, clear signing prompts, and full logging, so every approval is understandable, authorized, and auditable. Embedded wallets reduce friction, but they do not remove responsibility. The investor may only see a normal app experience: onboarding, funding, receiving tokens, and viewing holdings. Behind that, the platform must decide how keys are created, who can authorize transactions, how recovery works, and whether the arrangement is custodial. Tools like MPC, passkeys, or social recovery improve usability, but they also create legal consent, audit, and compliance obligations that must be designed upfront. Account abstraction moves wallet behavior from a simple key-controlled account into programmable logic. Instead of requiring every investor to hold gas tokens and manually approve each action, a smart account can validate transactions against rules first. That enables sponsored fees, spending limits, delegated access, batching, and recovery workflows. In an ERC 4337 style model, user operations pass through bundlers and an entry point, so enterprises must diligence paymasters, smart account code, chain support, and new attack surfaces. Key protection in enterprise systems extends beyond wallet custody. The same control model must cover API keys, certificates, database passwords, signing keys, recovery material, and emergency access. Cloud KMS is usually the simplest fit for cloud-native encryption and access control. Managed HSMs add stronger isolation for regulated signing. Vault platforms excel at dynamic secrets, leasing, and policy. On-prem HSMs remain useful when sovereignty, latency, or legacy compliance requirements dominate. In production, custody is only one part of the pattern. The platform must separate wallet roles, route every transaction through orchestration, compliance, approvals, and audit logging, and keep enterprise secrets in KMS, HSM, or Vault services. Clear trust boundaries matter. Know what the vendor controls, what the enterprise controls, and what lands on chain. Design the unhappy paths too: outages, congestion, failed signatures, policy exceptions, emergency pause, and recovery. The main takeaway is that wallet architecture is not just a UX choice. Custody providers, integration patterns, and key protection services shape security, compliance, resilience, and operational control. You're now ready to move from evaluating options to designing concrete wallet security policies and interoperability controls.